Video presented to you by Unique to Billions eLearning. Please subscribe it and press the bell icon. Measurement and errors. This video includes all topics in measurement and errors based on Chapter 2 of Class 11 Units and Measurement. Last part of this video, we will do one problem which was asked in JEE Main examination from this topic. So watch till the end. Let us start with measuring length of a pen. If we measure the length of pen using a centimeter scale as shown in figure, we get a measurement. From the figure, it is clear that the measurement is correct up to 10 centimeter, and after that there is an uncertainty in the measurement. We are not sure how much is the length exact. If I measure the same pen with a millimeter scale on which millimeter marks are made, we get a measurement. By looking into this figure, we can say the measurement is 10.3 centimeter. It almost looks correct by just looking into it. Let us see a magnified picture of this one. By looking into the magnified picture, we can see that it is correct up to 10.3, but there is an uncertainty in this measurement. This shows that every measurement by any measuring instrument contains some uncertainty. This uncertainty in measurement is called error in measurement. If the exact measurement of length of this pen is 10.34 centimeter, then by measurement with millimeter scale is close to the correct length than the measurement with a centimeter scale. But there is a difference in the limit or measuring instrument also. So there are two terms we need to study here. They are accuracy and precision. Accuracy of a measurement is the measure of how close the measured value to the true value of the quantity. Precision tells us to what resolution or limit the quantity is measured. In our measurement of the length of pen, we can see the measurement with the millimeter scale is more accurate than the measurement with a centimeter scale. Precision tells us that the measurement with millimeter scale is measured with a precision of 1 millimeter, that is 0.1 centimeter. The precision in centimeter scale is 1 centimeter. So that is accuracy and precision. Accuracy in a measurement may depend on several factors, including the limit or the resolution of the measuring instrument. But there is always an error in measurement. The error in measurement can be divided mainly as systematic errors and random errors. Now we are going to study systematic errors and random errors. First, systematic errors. Systematic errors are those errors whose cause are known. This error happens due to a reason or cause. So they tend to be in one direction, either positive or negative. Since the cause of this error are known, it can be minimized. Few causes of systematic errors are: 1. Instrumental errors. That is, the error in measurement due to error in instruments. The error may be due to error in calibration, zero error, imperfect design, etc. For example, your weight may be measured more or less if the needle on the weighing machine is not point to 0 initially. This error can be minimized by using more accurate instrument and applying zero correction when required. Second cause of systematic errors is imperfection in experimental techniques or procedure. External factors or conditions like temperature, humidity, pressure, etc. can affect measurement in some cases. Ignoring certain facts while doing experiment can also cause error in measurement, like avoiding air resistance in simple pendulum experiment. This error can be minimized by improving experimental techniques or applying proper correction to the measurement. Third cause of systematic errors is personal errors. This error is due to individual bias or carelessness in taking observations without observing proper precautions. Error due to parallax is an example of such errors. This error can be minimized by removing personal bias as far as possible. Second type of error is random errors. Random errors are those errors which occur irregularly and hence are random with respect to sign and size. The causes of random errors are unknown. This can arise due to many reasons like unpredictable fluctuations in experimental conditions. Since the reason for this error are unknown, they cannot be avoided completely. This error can be minimized by repeating the experiment large number of times and taking arithmetic mean of all the observations. Least count error. In our measurement earlier, we see that the smallest value that can be measured from a centimeter scale is centimeter and for a millimeter scale is millimeter. This smallest value that can be measured by the measuring instrument is called its least count. So, least count is the smallest value that can be measured by the measuring instrument. All the readings or measured values are good only up to this value that we already seen in our measurement. So least count error, the error associated with the resolution of the instrument. Now we are going to study absolute error. The magnitude of the difference between the true value of the quantity and the individual measurement value is called the absolute error of the measurement. The absolute error of a physical quantity is denoted as delta A, shows magnitude only. Usually, the mean value of the measurement is taken as the true value. Suppose the values obtained in several measurements are A1, A2, A3, etc. up to AN. Then the arithmetic mean of the measurements A mean is equal to A1 plus A2 plus etc. plus AN divided by N, that I can write as sum of I is equal to 1 to N AI divided by N. Therefore, the errors in individual measurements are given by delta A1 is equal to A mean minus A1, delta A2 is equal to A mean minus A2, like that. Delta AN is equal to A mean minus AN. The value of delta A can be positive or negative. But remember, absolute error is always positive. So we are going to study next topic, mean absolute error. The arithmetic mean of all the absolute errors is taken as the final or mean absolute error of the value of the physical quantity A. This is represented as delta A mean. Therefore, delta A mean is equal to delta A1 plus delta A2 plus etc. plus delta AN divided by N. That I can write as sum of I is equal to 1 to N delta AI divided by N. That is, the value we get for one measurement may be in the range A is equal to A mean plus or minus delta A mean. That is, A mean minus delta A mean is less than A mean plus delta A mean. The relative error or fractional error is the ratio of the mean absolute error delta A mean to the mean value A mean of the quantity measured. So relative error is equal to delta A mean divided by A mean. Now, percentage error. When relative error is expressed in percentage, it is called percentage error. That is, percentage error is equal to delta A mean divided by A mean into 100%. So here we studied different terms and equations related to error. The next section we are going to study is combination of errors. Most of the experiments require several measurements and the formula include mathematical operations. So, it is important to know how the errors in all measurements are combined in various mathematical operations. In this section, we are going to study combination of errors, specifically errors of a sum or a difference, errors of a product, errors in division, errors in case of a measured quantity raised to a power. And last, we will do a problem which was asked in JEE Main 2015. Errors of a sum or a difference. Consider two physical quantities A and B have measured values A plus or minus delta A and B plus or minus delta B, where delta A and delta B are their absolute errors. Let Z is equal to A plus or minus B, and the absolute error for Z is delta Z. Then I can write Z plus or minus delta Z is equal to A plus or minus delta A plus or minus B plus or minus delta B. Rearranging, I can write A plus or minus B plus or minus delta A plus or minus delta B. A plus or minus B is Z, therefore I can write Z plus or minus delta A plus or minus delta B. Simply delta Z is equal to plus or minus delta A plus or minus delta B. So, the error delta Z can take four possible values. They are plus delta A plus delta B, plus delta A minus delta B, minus delta A plus delta B, minus delta A minus delta B. The maximum value of absolute error is equal to delta A plus delta B. So, I got an equation for the combination of errors for a sum or a difference. So, what is the rule? The rule is the absolute error in the final result is the sum of the absolute errors in the individual quantities. Now we are going to study error of a product. Let the measured value of two physical quantities A and B are A plus or minus delta A and B plus or minus delta B respectively, where delta A and delta B are the absolute errors in the measurement of A and B respectively. Let Z is equal to AB and the absolute error for Z is delta Z. Therefore, I can write Z plus or minus delta Z is equal to A plus or minus delta A into B plus or minus delta B. Multiplying this, I can write it as AB plus or minus A delta B plus or minus B delta A plus or minus delta A delta B. We know Z is equal to AB, therefore I am going to divide the LHS with Z and the RHS with AB. I will get 1 plus or minus delta Z by Z is equal to 1 plus or minus delta B by B plus or minus delta A by A plus or minus delta A delta B divided by AB. Here delta A delta B divided by AB is a very small quantity, can be neglected, and 1 will cancel off. So I can write plus or minus delta Z by Z is equal to, I am just interchanging this one, plus or minus delta A by A plus or minus delta B by B. Here also we can see there are 4 possible values, but the maximum relative error is delta Z by Z is equal to delta A by A plus delta B by B. The rule is, when two quantities are multiplied, the relative error in the result is the sum of the relative errors in the multipliers. Now we are going to study errors in division. In the same way as we took in the previous cases, let A and B are two physical quantities with measured values A plus or minus delta A and B plus or minus delta B. Let Z is equal to A by B and delta Z is the absolute error of Z. I can write Z plus or minus delta Z is equal to A plus or minus delta A divided by B plus or minus delta B. Taking out Z from LHS, I can write Z into 1 plus or minus delta Z by Z is equal to, taking A from numerator and B from denominator outside, I can write A into 1 plus or minus delta A by A divided by B into 1 plus or minus delta B by B. But we know Z is equal to A by B, so it can be cancelled out. Therefore, the equation becomes 1 plus or minus delta Z by Z is equal to 1 plus or minus delta A by A divided by 1 plus or minus delta B by B. This can be written as 1 plus or minus delta Z by Z is equal to 1 plus or minus delta A by A into 1 plus or minus delta B by B the whole raised to minus 1. Expanding 1 plus or minus delta B by B the whole raised to minus 1 binomially, and we also know that delta B by B is very less than 1. So we can write 1 plus or minus delta Z by Z is equal to 1 plus or minus delta A by A into 1 minus or plus delta B by B. Expanding the bracket, I can write it as 1 plus or minus delta Z by Z is equal to 1 plus or minus delta A by A minus or plus delta B by B minus or plus delta A by A into delta B by B. This delta A by A into delta B by B is very small, so can be neglected, and 1 can be cut it out. So I can write here it as plus or minus delta Z by Z is equal to plus or minus delta A by A minus or plus delta B by B. Here also 4 possible values for this, but the maximum relative error is delta Z by Z is equal to delta A by A plus delta B by B. So the rule is, when two quantities are divided, the relative error in the result is the sum of the relative errors in the individual quantities. Now we are going to study error in case of a measured quantity raised to a power. Let Z is equal to A raised to n. I can write it as A into A into A into n times. We already know relative error of product of measurement is the sum of the relative errors. Thus, I can write it as delta Z by Z is equal to delta A by A plus delta A by A plus delta A by A plus n times. What is delta A by A plus delta A by A plus delta A by A plus etc. up to n times? It is simply n into delta A by A. So I can write it as delta Z by Z is equal to n into delta A by A. So the rule is, the relative error in a physical quantity raised to a power n is n times the relative error in the individual quantity. So in general, if Z is equal to A raised to L, B raised to M divided by C raised to n, then the relative error delta Z by Z is equal to L into delta A by A plus M into delta B by B plus N into delta C by C. So this can be used to find the relative error in a formula. Before concluding this session, we are going to do a problem which was asked in JEE Main 2015 examinations. Question: the period of oscillation of a simple pendulum is t is equal to 2 pi square root of L by G. Measured value of L is 20.0 centimeter, known to 1 millimeter accuracy, and time for 100 oscillations of the pendulum is found to be 90 seconds using a wristwatch of 1 second resolution. What will be the accuracy in the determination of G? Here it is given t is equal to 2 pi into square root of L by G. Therefore, I can write G is equal to 4 pi square L by T square. We know the time period T is equal to T by N, where small t is the time measured and N is the number of oscillations. Substituting here, I can write G is equal to 4 pi square L divided by T square by N square. Rewriting this, I can write it as 4 pi square N square L by T square. 4 pi square N square is constant, so it is not changing with the measurement. The values it changed with the measurement is L by T square. Therefore, I can write the relative error delta G by G is equal to delta L by L plus 2 into delta T by T. Substituting the values given in the question, I can write delta G by G is equal to delta L by L. Delta L is 1 millimeter and L is 20 centimeter. So, writing 1 millimeter in terms of centimeter, it will be 0.1 divided by 20 plus 2 into delta T by T. Delta T is 1 second and T is 90 seconds. So, 1 divided by 90. This answer can be calculated as 0.0272. Converting it into percentage by multiplying with 100, I can write delta G by G into 100, that is equal to 2.72 percentage. So, the percentage error in the measurement of G is equal to 2.72 percentage, that is approximately 3 percentage. So, the accuracy in the determination of G is 3 percentage. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.